Hello and good evening to all of you. Welcome to Resultant JE YouTube channel. I'm Vikas Sir and I welcome you all to this session on fluid mechanics, practice power hour, where we are going to practice some important questions. In one complete hour, we are going to discuss important questions on the subject of fluid mechanics. And those who are preparing for RRB JE exam, obviously most of you must be thinking. Firstly, there will be CBT1, then after that CBT2 you have to prepare for CBT2. But if you prepare for CBT1, CBT2 together, then there will be more chances of selection, because your preparation will be, you will be prepared in advance for CBT2 as well. Also, after announcement of SSC JE CBT1 result, paper 1 result, I know that many of you must be thinking that now you have to prepare for CBT2 as well for SSC JE. So these sessions will be helpful for both SSC JE CBT2 and RRB JE CBT2. First of all, congratulations to everyone, those who are able to clear those who have cleared the SSC JE paper 1, as the results have been announced. I think most of you must have seen your name. Hello Pushpendra, Anand Pratik, MS, good evening, welcome to a session. So very good evening everyone, welcome to a session. I hope, so yesterday the SSC JE CBT1 result was announced, and I have seen many students have told me personally that sir, I have got selected. I think Subho, one of my students, have cleared the CBT1 exam, and he was preparing from very long time, but finally he has been selected for paper 2. That means he has cleared paper 1 of SSC JE. And if any one of you have also cleared the CBT1 of SSC JE, and definitely after clearing that exam, you have to clear the SSC JE CBT2 also, which is totally technical, and for that you have to study these subjects. And the weightage are, the high weighted subjects are thermodynamics, applied thermodynamics and fluid mechanics. Okay, you have also cleared MS, very good, congratulations. Hi Prisma, good evening. Sanado Siddiqui, good evening. So good evening everyone, welcome to a session. Let's start the session. My dear students, if you have not yet subscribed our YouTube channel, then please do not forget to subscribe and press the bell icon. Also, those who have joined me for this session, please hit the like button and also please share the session. This is my introduction. As you can see, something has been written about me, especially about my name. This is my name, Vikas Sir, and this is my total teaching experience. These are the subjects that I have taught for so many years, mentored more than 1 lakh students for different competitive exams, which include GATE, engineering services, SSC JE and many other examinations, where I have so many students have got selected after studying from me. It's not that I was the only teacher, but the subject that I have taught have definitely the students have got benefited. As you can see, the name of the subjects. So these are the faculties. First of all, I want to tell you that at Resultant we are providing you RRB JE course, where these 4 faculties, along with me, these 3 other faculties will be taking the technical subjects of RRB JE. And we have basically 3 type of courses currently at Resultant related to RRB JE. One is for CBT1 called Focus Batch, one is for CBT2 called AIM Batch, and one is called Mission Batch for both combined CBT1 and CBT2 of RRB JE. Those who are interested, you can give a call on this number or you can just mail us here. Hello Gautam, good evening, welcome to the session. AIM batch is only for CBT2 of RRB JE. Those who want to prepare for RRB JE CBT2, you can just prepare from our AIM batch. And Mission batch is combined batch for a combined course for CBT1 and CBT2, where we'll be covering the mechanical part and also non-technical part of CBT1. Coming to the first question of today's session, today we are going to discuss questions on fluid mechanics, and tomorrow we are going to discuss questions on power plant Okay, promotion last May. Okay. See, the team has asked us to put the promotions in the start. Most of the case, faculties follow what has been told to us by our team, but if you think that promotion should come in the last, then I will definitely put them in the last. In case of transmission of hydraulic power by a pipeline to a turbine in a hydroelectric power station, the maximum power transmission efficiency through the pipeline is. I hope you remember this, that the power transmission through the pipeline, the theoretical power transmission through the pipeline is equal to rho g q h. This is the total theoretical power. The actual power transmission through the pipeline, because of the losses in the pipeline, will be equal to rho g q h minus hf. What is hf? Hf is the head loss due to friction. So if you have to find the efficiency of the power transmission, this will be equal to actual power transmission divided by theoretical power transmission. This will give you, if you solve it, you will get h minus hf by h. If you want to have maximum efficiency, condition for maximum efficiency is that when head loss due to friction becomes 1/3 of total head. If you put this value hf is equal to h by 3, you will get maximum efficiency of power transmission is equal to 66.6%, that is 67%. Clear? Is it clear to all of you? Next question. A pipe having a length of 200 meter and 200 mm diameter with friction factor of 0.015 is to be replaced by 400 mm diameter pipe of friction factor of 0.012 to convey the same quantity of flow. The equivalent length of the new pipe for the same head loss will be. Well, this question, two things are given this question. One is the head loss is same, another is the discharge is also same. So if we are having two pipes, the head loss is equal to FL Q square by 2GD. This is not the FLQ square. If you have to write in terms of discharge, it will be 12 d power 5. This is a formula in terms of discharge. If you have to write the head loss in terms of velocity, it will be FLV square by 2GD. But why I am using this formula, not this formula? Because here discharge thing is mentioned. Because discharge is given, that's why I will be using this formula. So if I equate the head loss in both the cases, head loss due to friction, if I equate them, this will be F1 L1 Q1 square over 12 D1 power 5 is equal to F2 L2 Q2 square over 12 D2 power 5. My dear students, since in this question it is given, it is mentioned, the discharge is same. Discharge is same, this will get cancelled out. Same quantity of flow is given. 12 will get cancelled out. Rest all the values are given this question. Just put those values and you will get the answer. Put those value. It is 12.1, but you can take approximately 12. Okay. Just put those values and you will get the answer. F is given. This is F1. This is L1. This is D1. D2 is given. F2 is given. You have to find L2. You will get the L2 if you just put all the values here. Come on. Please, I want all of you to try this question. And please use your calculator. Okay, for more accuracy, for better result, the L2 will be equal to F1 by F2, F1 by L2, F2 into L1 into D1, into D2 by D1 power 5. Just solve this F1 is equal to 0.015 over 0.012 into L1 is equal to 200 into D1 by D2. D1 is how much? 200. Sorry, D2 is 400 by 200 power 5. Okay, please try to solve this question. So this will be 0.015 divided by 0.012 into 200 into 32. Yes, use calculators, try to solve this question correctly. If you use calculator, you will get exact answer, and exact answer will be 8,000 meter. Okay, 8,000 meter. Are you all getting this value? Please let me know. Just a second. Are you all getting this value? Not approximate. I don't want approximate answer. You should get the exact answer. And if you use the calculator, you will get exact answer of 8,000 meter. Are you all getting this value? I hope you all getting this value. Okay, understood the question. Next question. A curve that is everywhere tangent to the instantaneous local velocity vector is called as. There are different types of line or curve mentioned: streak lines, path line, normal line, streamline. Now we are talking about a curve that is everywhere tangent to the instantaneous local velocity vector. You must have read about the streamlines. So streamlines are the imaginary curve, and if you draw tangent on these streamlines, which are imaginary curves, then these tangent will give you the direction of velocity vector. So these imaginary lines are called as streamlines, over which if you draw a tangent, you will get the direction of instantaneous local velocity vector. So that is called streamline. Okay, very good. Next question: for fully developed laminar pipe flow, the average velocity is. For fully developed flow, when we say pipe flow, we are talking about the flow through pipe, and we are talking also about the fully developed flow. So when we say fully developed flow, initially if you see, when the flow takes place inside a pipe, then the velocity profile tends to vary like this. But after some time, the variation becomes uniform. That means there is no variation of the velocity profile. The point after which the velocity variation is stopped, that is called as hydrodynamic length. After that, the flow is called fully developed flow, and the velocity profile will stop changing its nature. Velocity profile will become constant. Okay. What is velocity profile? That is u by u infinity. This is called as velocity profile. The velocity profile will not vary in the direction of the flow. Will not vary with direction of flow. That is called fully developed laminar flow. Now, in case of laminar flow through the pipe, the average velocity is equal to half of maximum velocity. Okay, the average velocity becomes half of maximum velocity, but this is only true for pipe flow. So when we say pipe flow, when we are talking about the pipe flow, then this is correct. But if we say about the flow through parallel plates, if we talk about the flow through parallel plates, fixed parallel plates, okay, if we discuss about the flow through parallel plates, here also the same condition happens. The maximum velocity is found at the center. At the center you will find the maximum velocity, but the average velocity will be equal to 2/3 of maximum velocity for the flow through parallel plates, parallel fixed plate. Clear? In this case, the answer will be option A, 1/2 of the maximum velocity. Consider the following statement about the losses in the pipe flow. Shock losses are the major losses in the pipe. Shock losses are major losses. Viscosity is a property of the fluid which account for major losses in the pipe. No, it is not 3 by 2. It is 2 by third if you are talking about the average velocity. Generally, we talk about the average velocity in terms of maximum velocity. So it is 2 by third of maximum velocity, average velocities. The head loss at the entrance of the pipe is half that of its exit. There are three statements mentioned here. Which of the following statements are correct about the losses in the pipe flow? So if you see the first statement, shock losses. What do you mean by shock losses? If you remember, when we discuss about the minor losses, there are different types of minor losses. And the types of minor losses are sudden expansion. Sudden expansion loss take place when the flow suddenly expands, passes through a small pipe to large pipe. Then sudden expansion loss take place. Similarly, sudden contraction. So when these phenomena happen, sudden expansion, sudden contraction loss, or bend loss, or entry loss, or exit loss, they all come under the minor losses. They are all shock losses. So they are minor losses, not major losses. Okay? हिंदी में नहीं पढ़ा सकते. I'm success with knowledge. The classes here we are providing are only in English. Okay? So here I can't teach you in Hindi. Viscosity is a property of a fluid which account for major losses. Yes, major losses you have studied Darcy-Weisbach equation. This is the equation which is used to calculate the major losses due to friction. Okay, and we say that major losses basically because of friction, and we also know that viscosity is basically a property of a fluid. The reason responsible for this viscosity is it is also called internal resistance to the fluid flow. It is also called internal resistance, and something when we say resistance, it is also a case of friction, right? It is also kind of a resistance. So it is internal resistance to the fluid flow. Okay, please explain Hindi. See, on this YouTube channel, it has been decided that the classes will be provided in English. Okay, because majority of the students can understand English but not Hindi. Okay, if I only teach in Hindi, then some part of the country people don't understand Hindi, but English is a language which is understood by everyone. So that is why I am teaching in English. The head loss at the entrance of the pipe is half that of exit. The exit loss you must have studied. The exit loss is equal to V square by 2G. Entrance loss is equal to what? Entrance loss is loss at the entrance of the pipe is equal to half of the exit loss. It is just half of the exit loss, which is 0.5 V square by 2G. Okay, so the right answer for this question is option C, 2 and 3. Clear? If you find anything which is you are not able to understand, I can speak that in Hindi also for you guys. Okay, you want anything that has to be explained? ऐसा कुछ है जो आपको लगता है कि मुझे हिंदी में एक्सप्लेन करना है तो आप मुझे बता सकते हैं. ओके, आई कैन डेफिनेटली एक्सप्लेन इन हिंदी. यस, शॉक लॉसेस क्या होते हैं? शॉक लॉसेस आर सडनली व्हेन द पाइप फ्लो, अचानक से जब फ्लो किसी छोटे पाइप से बड़े पाइप में जाता है तो एक शॉक लॉसेस, उसको हम सडन एक्सपेंशन लॉस कहते हैं. एक बड़े से छोटे पाइप में जा रहा है फ्लो, दैट इज sudden contraction. Similarly, we have bend losses और entry loss, exit loss. ये सब आपके minor loss होते हैं और ये shock losses के अंदर आते हैं. ओके, बाकी इनमें से कोई भी प्रॉब्लम है तो आप मुझे बता सकते हैं. Consider the following statement about meta center. It is a point at which line of action of the force meets the normal axis of the body when it is given angular displacement. See, meta center you all have studied. It is a point. It is a point which is denoted by M, and this point is basically, it is responsible for stability of floating body. Basically, when we have to study the stability of a floating or partially submerged body, then this point meta center plays a very important role. ये बहुत important role play करता है जब हमें किसी floating body की, when we have to study stability of floating body. Okay. And what is this point? Meta center is definitely a point. And how you get this point? अगर मान लेते हैं कोई फ्लोटिंग बॉडी है, उस फ्लोटिंग बॉडी को हमने एक एंगुलर टिल्ट दिया है, उसको एक डिस्प्लेस किया गया है ना, अपनी पोजीशन से एक एंगल पे डिस्प्लेस करते हैं. इफ यू डिस्प्लेस इट फ्रॉम इट पोजीशन, देन द लाइन ऑफ एक्शन ऑफ द फोर्सेस, विच फोर्सेस? सेंटर ऑफ बॉयंसी, सेंटर ऑफ ग्रेविटी, उनके जो लाइन ऑफ एक्शन है वो एक पॉइंट से मिलते हैं. दैट पॉइंट इज कॉल्ड एज मेटा सेंटर. सो दिस इज करेक्ट. It is an intersection of the line passing through new center of buoyancy and center of gravity. It is a point about which bodies start oscillation when it is given small angular displacement. All the points which are mentioned about meta center are correct. ये तो आपको समझ में आ गया होगा. I think all of you have marked the answer correctly. And those who want me to explain in Hindi, जो चाहते मैं हिंदी में explain करूँ, देखिए आपके एग्जाम में जो क्वेश्चंस होंगे, the questions in your exam will be in English language. राइट हाँ, मैं आपको हिंदी में एक्सप्लेन कर सकता हूँ. आई कैन एक्सप्लेन इन हिंदी ऑल्सो, बट अल्टीमेटली यू हैव टू आंसर दीज क्वेश्चंस इन इंग्लिश लैंग्वेज ओनली. दैट मीन्स यू हैव टू रीड द क्वेश्चंस इन इंग्लिश एंड गिव द आंसर्स राइट अकॉर्डिंगली. ओके. इन द फुली डेवलप्ड लैमिनार फ्लो थ्रू अ हॉरिजॉन्टल पाइप ऑफ कांस्टेंट क्रॉस सेक्शन. कांस्टेंट का मतलब होता है, क्रॉस सेक्शन का मतलब होता है एरिया. यानी कि अगर किसी हॉरिजॉन्टल पाइप का कांस्टेंट एरिया है, इफ यू हैव अ हॉरिजॉन्टल पाइप एंड दैट हॉरिजॉन्टल पाइप हैज अ कांस्टेंट एरिया, दैट इज डायमीटर इज कांस्टेंट, एरिया इज कांस्टेंट मींस डायमीटर इज कांस्टेंट. ओके. सो थ्रू आउट द डायमीटर इज कांस्टेंट, इट इज नॉट हैविंग अ वेरिएबल डायमीटर. अब एक फुली डेवलप्ड लेमिनार फ्लो हो रहा है इस पाइप के अंदर. Then what can we say about the static pressure? Static pressure means constant in the direction flow. Let us say that flow, this is the direction of the flow. Flow is direction में आपका हो रहा है. Direction of flow is this. ठीक है, this is direction. अब ये बताओ कि इसमें क्या, कौन सा क्वेश्चन. एंड वी आर टॉकिंग अबाउट fully developed flow. Fully developed flow we are talking about through horizontal pipe. First statement, static pressure remains constant. Does pressure remains constant? आपने इस केस में पढ़ा हुआ है that pressure will decrease in the direction of flow. You must have studied about that. This is called negative pressure gradient. If really you know understand, अगर आपने कभी पढ़ा हुआ है कि जब फ्लो होता है तो फ्लो हमेशा कहां से कहां होता है. इट ऑलवेज टेक प्लेस फ्रॉम हाई प्रेशर. इट फ्लो टेक प्लेस फ्रॉम हाई प्रेशर टू लो प्रेशर. सो दैट मीन्स इफ दिस इज एक्स डायरेक्शन, दिस इज एक्स डायरेक्शन. सो इन दिस एक्स डायरेक्शन, if you see the flow, then pressure will decrease in the direction of the flow. The pressure will decrease in the direction of the flow. Are you getting my point? So this answer is correct. Static pressure will decrease in the direction of the flow. Clear? Bernoulli quotient holds along the axis of the pipe. Bernoulli quotient holds along the axis. If you have any idea about this fully developed flow, you know that in the fully developed flow, this boundary layer develops. Have we studied about the boundary layer? The boundary layer develops from the axis of the pipe like this and like this. And if you see somewhere on the center of the pipe, is there any possibility that in the center of the pipe you will not find the boundary layer? There will be a boundary layer. Okay, and you know that on the boundary layer and inside the boundary layer, Bernoulli quotient is not eligible. So axis of the pipe is actually the boundary layer. This axis of the pipe is nothing but It is a boundary layer. So boundary layer will be formed on the somewhere on the axis of the pipe. So definitely you will not find the Bernoulli equation holding here. Bernoulli equation वहाँ पे hold नहीं करेगी, because if you have studied the concept, let's say this is a pipe, एक pipe है. अब पाइप का भी तो सरफेस होता है ना, तो इस सरफेस से भी एक बाउंड्री लेयर जाएगी, यहां से भी बाउंड्री लेयर जाएगी. तो सेंटर पे आप देखोगे, सेंटर ऑफ द पाइप यू विल फाइंड दिस बाउंड्री लेयर इज फॉर्म्ड. ओके, so because of that Bernoulli equation will not hold on the axis of the pipe, but static pressure will definitely decrease in the direction of the flow. Next, a liquid compressed in the cylinder from a volume of 0.04 meter cube at 50 kg per centimeter square to a volume of 0.039 meter cube at 150 kg per centimeter square. The bulk modulus of the liquid is. You have to find the bulk modulus. Bulk modulus is equal to increase in the pressure to the decrease in the volume over original volume. This is a formula. Okay, bulk modulus of elasticity. Now increase in the pressure, you can see the pressure is definitely increasing from 150 to 50. That is 50 से 150 pressure increase हो रहा है. So this is increase in pressure. The volume is decreasing, so it is change in the volume. So final volume is 0.039 minus 0.04 over original volume is 0.04. Just solve this and you will get the answer. Tell me what is the answer. Sorry, and this is my friend is 40 10 की power 5, 40 10 की power 6. This is in power, not multiplied here. Clear? Try to solve this everyone and tell me the answer. Okay, if you solve this, you will get 4000 kg per centimeter cube. You don't have to check the units because bulk modulus की unit वही होगी जो pressure की होगी, because pressure has a unit of kg per centimeter square. So bulk modulus will be having unit of kg per centimeter square. So you don't have to change the units here. Anyways, units are not changed, so you have to you just have to do the calculation. If you know the formula, you will get the answer. The only correct statement related to hydraulic turbines among the following is. There are some statements given about hydraulic turbines. You have to tell which of the following statements are correct. Pelton wheel and Francis turbine are impulse turbine. Pelton wheel and Francis turbine impulse. अब देखिए इसमें हिंदी में क्या एक्सप्लेन करूं मैं. पेल्टन व्हील आपने इंग्लिश में नाम पढ़ा है, फ्रांसिस, राइट. दे आर इम्पल्स टर्बाइन, वो इम्पल्स टर्बाइन है. अब यही तो होगा इसका मतलब. एडजस्टेबल ब्लेड कैप्लन टर्बाइन हैज अ हायर पार्ट लोड एफिशिएंसी कंपेयर्ड टू फ्रांसिस. देखिए, दिस इज रॉन्ग बिकॉज पेल्टन इज अ इम्पल्स टर्बाइन and Francis is a reaction turbine. So this statement is wrong. Draft tube can improve the performance of Pelton wheel. Wrong, because draft tube is used with reaction turbine. Draft tube is used with reaction turbine. So obviously the statement is wrong. Cavitation occurs at entry to Francis turbine. Cavitation occurs at exit to a reaction turbine. So this is wrong. So only answer which is correct is option B. The adjustable blade. Do you understand the meaning of adjustable blade? Kaplan turbine has got 4 to 6 adjustable blades. And because of having adjustable blade, not just Kaplan turbine has full load efficiency, it can also offer part load efficiency as compared to Francis turbine. So that is an advantage. The main function of the draft tube in a hydraulic reaction turbine is to reaction turbine में draft tube definitely use होती है. We know that it is used at the exit of reaction turbine. At the exit of reaction turbine, you will find the draft tube. So, but why we use this reaction turbine? Draft tube at the exit of reaction turbine. It is 4 to 8 blades are used. It is used to reduce the effective head across the turbine, increase the discharge and hence the work increases, decrease the discharge to prevent flow separation, or increase the effective head. So if you have studied the function of draft tube, the function of draft tube includes increasing the effective head. Why we use draft tube? Draft tube function. The main function is to increase effective head. What do you mean by effective head? Any idea? Do you have any idea about the effective head? कभी पढ़ा है? देखिए, एक होता है ग्रॉस हेड. One is gross head. Okay. One is net effective head. Okay. So to increase the net effective head across turbine, we use a draft tube. And second is to convert kinetic energy at exit of turbine. Reaction turbine has got lot of kinetic energy at exit to pressure energy. So this is the main purpose of using a draft tube. Okay, to increase the net effective head and to convert kinetic energy into so net effective head is basically, gross head is this, net effective head is gross head minus head loss due to friction. Okay, so that is net effective head. One short session on boundary layer, 11 hours of layer, boundary layer. Sure. Next I will definitely try to take some sessions, theory session on this fluid mechanics and or maybe some subjects, important topics related to thermodynamics or fluid mechanics. Okay. What is the next month I will take this kind of session. What is the function of surge tank? Like we say, draft tube is something which is related to a reaction turbine. Likewise, surge tank is we basically use for Pelton turbine. Wherever we have a turbine, because Pelton turbine is a turbine, mostly it is also called high head turbine. High head means what is the meaning of head of the turbine? So the point from where the water starts flowing through a pipe called as penstock, and to the point where the water is actually delivered, this point from where water is stored to this point, okay, this is called as H. This is called as net effective head. Now, if this head of the turbine is greater than 250 meter, it is called high head turbine. If the water is flowing from this high head, and suppose that there is some wall at this point, there is some wall here, and suddenly the water which is flowing at very high pressure, अचानक से इस wall को बंद कर दिया जाता है. If the wall is closed suddenly, then what will happen? This water pressure will try to impact the pipe wall. It will try to put pressure on the pipe wall, the wall of the pipe. So to prevent this, and because of that, the walls can get damaged, the pipe can damage. To prevent this, we install a tank here. This is called surge tank. So the main function of surge tank, the main function is, in this kind of situation where the wall is suddenly closed because some अनप्रेसिडेंटेड रीजन, किसी कारण से अगर वॉल को अचानक से बंद करते हैं तो वाटर हैमर का इफेक्ट ना हो, वाटर हैमर यू मस्ट हैव स्टडीड, to avoid water hammer effect, this suddenly if the wall is closed then this water will go into this tank, this is called as surge tank, and whenever we require more water then from this surge tank this water can be also provided. So this is the main purpose we provide surge tank, to protect the pipelines due to rise in pressure when the water is brought to rest suddenly. This is basically called as the main function of surge tank, but basically we use it for Pelton turbine, okay, which is a high air turbine. Consider the following statement regarding velocity potential function. Velocity function, potential function denoted by this, it is also called a scalar function of x, y, z, which is, it is a three-dimensional scalar function. Okay, and if you derivate this scalar function in a given direction, let's say in x direction, if you derivate it, you will get the velocity in that direction. Negative derivative of this scalar, this velocity potential function in a given direction will give you the velocity in that direction. Okay, this is the point, important thing about the velocity potential function. Now there are three statements given here about the velocity potential function. First statement, if velocity function exists, the flow should be irrotational, right? And I don't know how many of you have studied this or not. Velocity potential function is also, velocity potential function exists only for irrotational flow. It exists only for irrotational flow. That means if the flow is irrotational, that means option 2 is not correct. That means option D is not correct. That means option C is not correct. That means option A is not correct. So only option that we are left with is option B. I always love this kind of questions where we are having many statements and we have to give the answers, because in these statement type questions where we have multiple statement, if you know what is right or maybe what is wrong, अगर आपको ये पता चल जाए कि सही क्या है या फिर गलत क्या है, you can easily get the right answer. Like this, you know second option is incorrect, then your answer comes out very easily. Third statement is, if velocity potential function satisfy the Laplace equation. What is Laplace equation? This. If velocity potential function this, you get this kind of result with velocity potential function. This is the Laplace equation. If velocity potential function satisfy the Laplace equation, then it will represent the possible steady incompressible irrotational flow. Okay. The loss of head due to sudden enlargement is attributed to. Attributed means attribution का मतलब, attribute is a quality. Is basically इसके पीछे कारण क्या होता है? जब आप sudden enlargement करते हैं, let's say we have a flow through a pipe, okay, and suddenly from this pipe the flow is taking place through a pipe of large diameter like this. So that means the flow is taking place from a pipe of small diameter to a large diameter pipe. So it is a case of sudden expansion. So whenever this sudden expansion thing happens, the flow is taking place through the small diameter pipe, and suddenly what will happen? This flow takes place in this pipe. So what will happen? Just imagine that something is flowing in this kind of pipe. Let's say you are this is a fluid. It is moving a small lane, like small road. Suddenly the roads becomes large or broad. So what will happen? The fluid which was flowing in this narrow space, suddenly the space will become wider, right? So this region you must see. In this particular region, what will happen? This kind of thing this kind of viscosity start to develop. This is called as eddies. These are called as eddy formation. So eddies are basically, they are kind of a viscosity, but they are because of turbulent viscosity. Okay, if you see the turbulent flow, whenever turbulent flow take place, so in case of turbulent flow, the loss of energy take place because of this eddy formation. Eddy is basically those kind of a rotational flow which try to reduce the energy, which try to consume the energy of the fluid. So here the fluid energy will get consumed. This region is called as eddy region. So because of this production and dissipation of the turbulent eddies, the loss of energy, loss of head means loss of energy, right? When we say loss of head, we are talking about loss of energy. So loss of energy take place. Okay. Consider the following statements. The locus of the points which represent sum of static pressure and elevation head is called energy gradient line. Energy gradient line, also known as EGL, or it is also called total energy line. But this line does not represent only two things, pressure and elevation. It represents three things: pressure head, elevation head, and kinetic head, which is also called velocity head. All these three heads, when these locus of these 3 points, these 3 types of energy head, when joined across a pipe, right? If you join those points, you will get a line. That line is called total energy line. So total energy line or energy gradient line represent the sum of these 3 types of energy head. That is pressure head, elevation head, also called datum head, and kinetic head or dynamic head. The hydraulic gradient line, which represent the elevation head, is always a distance v square 2g below EGL. Hydraulic gradient line is not just elevation head. Hydraulic gradient line is basically pressure head plus datum head. It is consist of both pressure and datum head. So this is also wrong statement. This is also wrong statement. In an idealized Bernoulli type flow, energy gradient line is horizontal. This is a right statement. This is correct statement. अब इनमें से कौन सा स्टेटमेंट सही हो सकता है? Which of the following statement is correct? None of the statement is correct as per the options given. एक भी statement सही नहीं है. Obviously, this is the engineering services previous year questions, and there is some mistake here. Hydraulic gradient line, option number 2, represent elevation head is always distant. No, it represents this elevation head plus pressure head, and it is a distance v square 2g below EGL. That is correct. This is correct, but this part is correct, but this is not correct, that it represents just elevation head. And likewise, locus of the point which represents sum of static pressure and elevation is not energy gradient, but it also includes this point. So option 1 and 2 are incorrect, only option 3 is correct, but none of the options given here are right. Oh, sorry, I think I have not seen this. Incorrect. Incorrect is written, not written together. So if it is incorrect, the answer will be 1 and 2, because they are asking incorrect. Incorrect means जो गलत है, are incorrect. This in is not written together, it has to be together. Which of the following statement is or are incorrect? Okay. 2 pipelines of equal length are connected in series. The diameter of the second pipe is 2 times that of first pipe. The ratio of the head loss between the first and second pipe is. Please focus on the question. Focus everyone. When the pipes are connected in series, when the pipes are in series connection, then first of all you need to understand why we connect the pipe in series connection. So when we connect multiple pipes in series connection, whether their diameter is different or same, okay, it doesn't matter. There can be same diameter pipe or they can be different diameter pipe. Let's say they are different diameter pipe like this, so that we can easily distinguish. The main function is, so main thing what happens, this is first, this is second, this is third, this is fourth. Discharge remains same, discharge in the pipe remains same, but the head loss will get added up. The head loss will increase when the pipe are connected in series connection. Okay, this is the concept. But here in this question it is being given, let's say two pipes are connected. Forget about that, we are not talking about three, we are just talking about two pipes. Just two pipes are connected in series. Two pipes are connected, no problem. So if there are two pipes are connected in series connection, then what will happen? The diameter second pipe is 2 times of first pipe, that is D2 is equal to 2 times of D1. But we have to find the ratio of the head loss. Head loss in the first pipe will be equal to FL Q square by F1 L1 Q1 square by 12 D1 की power 5. And second pipe will the head loss will be this. अब आपको लग रहा होगा, you must be thinking, sir, how to solve this question, because we have no idea about discharge, length, friction factor, nothing is given. So we don't have to, अगर नहीं है given तो आपको करना भी नहीं है, because we have to find the relation between the head loss with respect to diameter. The diameter is given, right? So what is the relation? What is the relation between head loss and diameter? It is inversely proportional to diameter power 5. Just use this relation. Ratio of the head loss between the first pipe and second pipe head loss will be equal to D2 by D1 power 5, right? D2 is equal to 2 times of D1. So this will be 2 power 5. 2 power 5 will be 32. 32 is to 1. Clear? Those who are giving option A as the answer, that means you are finding the, like Subhadeep, you are giving, if you are giving the answer for this question, then I am saying, then you are giving head loss of second by first. But in this question, you have to find the ratio of head loss of first by second. So when we say first by second, then that means it will be the ratio of diameter, second diameter to the first diameter power 5. Second diameter is twice of first diameter. So 2, this will get cancelled out, D1, D1, this will be 2 power 5. 2 power 5 is 32. Okay. Identify the incorrect statement. In laminar pipe flow, velocity distribution is parabolic. When we say laminar pipe flow, velocity distribution is parabolic. Yes. The velocity distribution is minus 1 by 4 mu del P by del X 1 minus R square by R square. This is a parabolic velocity distribution. This is a parabolic velocity distribution. If you see the velocity profile also, the velocity profile in the laminar pipe flow is like this. This is a parabolic velocity distribution, correct? But here you have to find the incorrect statement. Loss of head is directly proportional to square of the velocity of the flow. When we are saying laminar pipe flow, see, I have told you the formula of head loss as this. Head loss is equal to FL V square by 2 GD, and it is also equal to FL Q square by 12 D power 5, right? But when we say laminar pipe flow, only for this case, you can write head loss as 32 mu VL by rho G D square, and you have to use this formula for head loss if we are talking about laminar flow. Okay. So for laminar flow, friction factor is equal to 64 by Nod's number. You have said this. Shear stress distribution is linear. This is correct. Okay. This is correct. This is correct. This is correct. This is correct. This is not correct. This is incorrect. Why it is incorrect? Because when we say laminar pipe flow, for laminar pipe flow, The head loss is directly proportional to velocity, not square. Okay, clear to everyone? Are you getting this, everyone? Next question. In a laminar pipe flow, water flows through a pipe of diameter 100 mm with center line velocity 20 meter per second. Then velocity of the fluid at a distance of 20 mm from the pipe surface is. How are you going to solve this question? So we have a laminar pipe flow case. Okay, just a second. So we know that center line velocity means velocity at the center. Velocity at the center of the pipe is 20 meter per second. At the center means center line velocity is at the radius. So this radius is equal to how much? 50 mm. So at 50 mm radius, the velocity is this 20 meter per second. Now you have to find the velocity of the fluid at distance of 20 mm from the pipe surface. 20 mm. That means somewhere here. At this particular point, you have to find what is the velocity at this particular point. So how you will find this? You know the relation. I have told you this relation, u is equal to u maximum 1 minus r square by r square. Do you know this relation? The maximum velocity is what? You know, this is the center line velocity, also called the maximum velocity. This is maximum velocity is 20. This velocity, this radius, there are two radius. One radius is r. This is r, small r. This is capital R. So this is 20 by 50 square. Just try to solve this. You will get the answer. Please, everyone. So if you solve this, you will get 16.8 meter per second. That means at this radius from the pipe wall at 20 mm distance, the velocity will be 16.8 meter per second. Clear to everyone? Is it clear to all of you or not? Have we solved this? So this is how you can, and this velocity is also called local velocity. What is the meaning of local velocity? Local velocity is the velocity which vary with some radius along the pipe. Okay, this is called maximum velocity, also called center line velocity. Maximum velocity is also called center line velocity. It is also called center line velocity. Okay, and r is also called local radius, which is used to vary along the pipe. This is called local radius. Okay, the speed of a reaction turbine is 250 rpm when the working under a head of 120 meter. The speed of the turbine when the head is changed to 90 meter will be. So basically in this question it is given the speed is varying with head of a reaction turbine. Do you have any, do you know any relation between speed and head? Any idea between the relation between speed and head? B आ रहा है. How you are getting B as answer? You are getting 12.8. Prisma? Are you getting option B as the answer? Just a second, let me check. Maybe I have done some mistake then. 20 and 50. 50. No, I am not able to understand. आप लोगों का answer. How are you getting option B? This will be 21 minus 0.16. This is 20 into 0.84. That is 16.8. How you are getting? R is we have to take R as a distance of 20 m from the pipe surface. 20 m from the pipe surface. So this is the surface of the pipe. This is the surface of the pipe. This is the pipe surface, right? Let's say this is the pipe surface, right? Okay. Now from the pipe surface, this is the velocity you have to find somewhere here, 20 mm. So local radius, from where you calculate the road radius? So local radius will be equal to, okay, so this is distance from the pipe wall, sorry. Distance from the pipe wall is y and radius is calculated from the center. This will be 30, yes, because radius calculation will be done from the center. So this r, this is r, this is r, my mistake, this will be 30, r will be 30. So distance from the pipe wall, distance from pipe wall is equal to y and local radius is equal to r, radius minus distance from the pipe wall. This will be 50 minus 20, 30 mm. Yeah, sorry, my mistake, this will be 30, not 20. Yeah, please solve it. Local radius will be, just a second. This is 20 and this will be 30. So you have to find at this distance. This is r, small r will be this, this is y. Okay, clear? So if you solve this, you will get the answer. Then I think you are getting 12.8 meter per second. Sorry. Yeah. Okay. कैसे 30 आएगा? Because actually distance from the pipe surface, they are saying distance from the pipe surface, and distance from the pipe surface is not the local radius, it is the distance from the pipe wall is denoted by this y, pipe surface. Local, see, radius calculation is always done from the center, right? Center से तो radius निकालते हैं हम लोग. So from center, this is the radius, total distance, but local radius will also be calculated from center. But actually the distance, see, this distance is given as 20. If this is 20 and this is 50, then local radius will be this distance, r. You have to find velocity at this distance. So this will be 30 mm. So this r calculation will be done from the center of the pipe. Okay, that is how you will get r. Clear? So ये 30 होगा. This will be 30, not 20. Thank you everyone for pointing my mistake. Clear? Yeah. So this is the distance from the pipe surface, because pipe surface is given, and local radius is distance from the center. Center से distance हम निकालते हैं. Next question, also the last question of today's session. The speed of a reaction turbine is 250 rpm when working under head of 120 meter. The speed of turbine when the head is changed to 90 meter. So see, if you have to make get the relation between the head and speed, then this is one relation, that speed is directly proportional to, this speed is directly proportional to square root of h, right? And this is called as unit speed. So from here you will get the speed of a reaction turbine is N1 is equal to 250 rpm and the head is equal to 120 meter. When the speed is when the head is changed to head is 90 meter, then speed is definitely going to reduce. So you can find N2 by N1 is equal to square root of H2 by H1. Put the values, you will get square root of 90 by 120. So N2 will be equal to 250 into square root of 90 by 120. Just solve this. 250 into square root of 3 by 4. Solve this. Tell me the answer. क्या आएगा आंसर, जल्दी बताइए. It will be 216.5. 216.5. Approximately 217 RPM. Clear? So that's all, my friends, for today. I hope you guys have enjoyed today's session. Rest of the questions, okay, let's take one more question, last question. A fluid jet discharging from 20 mm diameter orifice has a diameter of 17.5 mm at its vena contracta. The coefficient of contraction will be, you must have studied the concept of vena contracta. That is, let's say we have a pipe, and this pipe we have installed an orifice meter you have studied. So when we studied the orifice meter, there is some point, this is the point of orifice, and after the flow has passed through the orifice, there will come a point that is called as vena contracta. Vena contracta is a point where the area becomes minimum. This is also called as theoretical point where the area becomes minimum. This is also called theoretical minimum area. And the actual minimum area will be this at the orifice. According to us, this will be actual minimum area. What is the coefficient of contraction? Coefficient of contraction is equal to ratio of area at the vena contracta to the area at the orifice. Just put the values and you will get the answer. Area, obviously it will be a circular one, so this will be pi by 4 d square. So we can directly write diameter. Diameter, this will be 17.5 divided by 20 square. Okay, you will get the answer. Tell me what is the answer you are getting. This is the last question for today's session. 0.875. This will be 0.77. 0.77 will be the right answer. Are you all getting this value? You have to do the square also. 17.5 by 20 square. When you do the square, you will get 0.77. Okay. Don't forget to square it. That's all. The rest of the question will be taken in some other sessions. And if you have joined us for this YouTube class and not subscribe our YouTube channel, then please do it. Please do subscribe our YouTube channel and press the bell icon, which is just next to the subscribe button. Also, do not forget to like and share the session. I'll see you tomorrow. Tomorrow will be a class on two important subject, which is RAC and power plant. Okay. There will be class on refrigeration, air conditioning and power plant tomorrow. Okay. Thank you so much for joining me for this session. I hope you all have enjoyed today's session. We have discussed many questions. I'll see you tomorrow on the same platform at 8 p.m. Thank you so much. Have a nice day. See you tomorrow at 8 p.m. Thank you, everyone.